Hello and welcome to today's class. For this class, we're looking at the concept of integration of trigonometric function using trigonometric identity. So we're looking at this concept, the case 3, under this concept. So do well to watch our previous class on the case 1 and case 2 under this concept. So for the case 1, I'll dropping the link to case 1. As you can see the link above you, right? So for the case 2, I'll also drop the link to the case 2 in the link you seen above you again. So case 1 and case 2, the link will drop above, as you can see them above you, right? Or perhaps you can check the description of this video. I'll drop the link to case 1 and case 2 for this concept. So let's dive into discussing case 3 under this concept. For case 3, what's the condition? What's the condition guiding case 3? For the case 3, I will have something of this nature. If I have the integral of cos ax, next up, cos bx with respect to the x. Last class was last class on case 1. That was sine and cos. Case 2 was cos and sine. Case 3 is now cos and cos. So how do you solve some? What will be the mathematical expression for solving this problem here? Such that the value of a, as we know, as usual, is always what? Greater than what? Than b, or perhaps must be greater than b. So for this one now, the mathematical expression becomes that same half integral into cos a plus b of x. So this becomes the expression for something of this nature, right? An integration of cos and cos such that a is greater than b. This becomes mathematical expression for this one here. All right. Let's now use this concept to solve some problem and let's see what we can do. So I'm having the integral. Let's say I have integral. I'm to evaluate the integral of cos 11x let's use 5x cos 3x with respect to the x. I'm going to evaluate something of this nature. So how do you go about this one? How do you solve it? Your priority is that, can you recall this expression? If you can't recall this, you can't solve it. Because this is a problem under what? Integration of trigonometric function using the idea of trigonometric identity, as you can see. So my first action is that I'll have an equal to and half integral into, this is square bracket. So into, observe the way I'm using my square bracket and round bracket. So into this is cos. I have cos into a plus b becomes, my a here is 5, my b here is 3. So a plus b means 5 plus 3. Attach x to it. This is a plus sign. Plus cos into a minus b is 5 minus 2. Sorry, minus 3. Attach x to it into what there? Into the x. At this point here, I have half the integral into cos 5 plus 3 becomes 8x. This x is this. This is a plus sign. Cos 2x. 5 minus 2 is 2x into, sorry, I'll use round brackets here. I'll use round brackets. Why? For the reason why I use square brackets is that I'm having a round bracket inside, so I have to use square brackets. You know, there's no more brackets, so I have to use round brackets. That's the idea. It's not that I just wish to use round brackets. No. So it's not making sense. I'll be having a bracket like this. Then cos brackets 5 plus 3. It looks more confusing. So let's separate this bracket. Must be somehow simplified, so it will make you know what you are doing. So I purposely use square bracket here, then round bracket here. Next up, the x. What's the next part at this point? pick out this one here, multiply with this half integral, multiply with this cos 8x, attach the x, I'm done. This is plus sign plus this half integral cos 2x. Next up, the x. What's your procedure here? I have half here. If you're familiar with our case 1, case 2, right, before now, you should know what to do here. So I'll have into this half here, into integrate cos 8x, I'll have sine 8x over 8. Don't ask me why. I'll explain this using the concept of case 1 and case 2. This case 3, you should know how I got to this. Alright, plus this is 1 over 2 into integrate cos 2x, I'll have sine 2x all over 2. Next up, plus c. Let's finish this one up here. Simplifying one better, 1 times sine 8x becomes sine 8x all over 2 times 8 is 16. This is a plus sign here, a plus. 1 times sine 2x gives sine 2x all over 2 times 2 is 4 plus c. This becomes my answer after solving a problem like this, as you can see. So this is like the concept behind integration of trigonometric function using the concept of trigonometric identity. Alright, see you in the next class. So we're going to be discussing about the case 3, and that's all for the concept of this idea. Alright, see you in our next class.